Hello students, welcome to your favorite channel Physique for NEET and JEE exam. Guys, this is Professor Shrenik Shah and here we are going for the second part of our series or a journey for mathematic tools required for physics. So guys, in the last lecture, in the last video, we have already done all the important formulas of trigonometry and I'm sure you have understood each and every formula, and I'm pretty much sure that if I take Viva right now, you all will be able to answer all the formulas because that is the most important part in it. And I'm sure you understood one important fact in that part is whenever you find the term as sine, cos, tan, sec, cosec, cot, you have to use trigonometry. There is no other thing which you can use and solve the sum. Okay, so we are done with the first part. Now we are going for the second part, and the second part we are going to deal with derivatives. Yes guys, we are going to deal with derivatives. Yes guys, first try and understand what exactly is this mathematical tool derivative is all about. Guys, let's say if I give you a bunch of stick, okay, a bunch of stick tied together firmly, and I ask you to break it. Don't you think it's going to be quite difficult task for all of you? But instead of that, if I give you one stick at a time to break, and ask you to break all the stick one by one and then say that I have broken all the stick. Isn't that task going to be much simpler, much easier to do? Yes guys, that's all derivative is all about. Whenever you get a huge problem or a huge difficulty, you break that into small components and you break it into such a small component that you can say hypothetically all the small components which you have broken into, they are all identical. Which means hypothetically if I say I have say a wire which is made up of length L and I break it into small parts, and that each part is so small, so tiny, so minimal compared to the entire length that I can say if the entire length is L, my each part is of delta L. A very tiny, very small part. Now can I say if all the parts are identical, then whatever logic, whatever formula, whatever concept I apply to this delta L, it should be applicable for all the delta L present in this L. So guys, don't you think with this, we are not talking about the huge problem of L, we are talking about the tiny problem of delta L. And whatever solution we apply for that delta L, we apply the same solution for all the delta L's, and then we find the solution to that big huge L. Isn't it sounding so great? Yes, derivative is that great. Basically, you are breaking your entire program or your entire problem into small parts, and those small parts you are applying the formulas to get the final answer. So guys, I'm going to discuss multiple things with you in this particular part, but for that definitely there are certain formulas which you again need to memorize, because as I said, for all the PCB students, derivation of those formulas does not make any sense, and so I would request you to understand the formula and to remember it rather than thinking about how this formula came up. Okay, so please, it's something like if you are going into a medical college and you are hand over certain tools and they tell you that this is say a scalpel, and with the help of scalpel you are going to hold or do such and such operation part in the operation theater. You never ask, sir, how this tool is made. Am I correct? You just use the tool and you understand how that tool is used. The same thing I'm asking from here, all the PCB students guys, mathematical tools which I'm teaching you right now is not something for you to understand how it is originated. For you it is important to understand how it is to be used. So guys, please try and understand this part and then watch the video. Okay, so let's go ahead. Yes, let's say I give you a very simple equation. which says y is equal to f of x. Yes, y is equal to f of x. Now what does this mean? I mean that here x is some independent variable and y is dependent variable on x using the function of x. So here the f of, when I say, it actually stands for function of x. So if I give you a very simple example for this, if I write y is equal to x square by 3. Okay, so can I say this is the equation of y in terms of x? So I can say basically this is nothing but function of x. This is the function of x, where if the value of x changes, the value of y gets affected. So when I say generally, it's called as y as f of x, the function of x. So guys, this is something which is a very basic thing, and you need to understand that this you are going to face multiple places. Okay. So when I say y is equal to x square by 3, I mean that if x is changed, y will change. But you can never say, guys, that if y will change, then x will change, because here I can say y is a function of x. Now, if you want to actually write for y, I can write x as root 3y. Correct? Then I have to write that x is function of y, where y becomes independent variable and x is dependent variable. And dependent variable on y. So guys, first thing you need to understand over here is whenever you are dealing with derivatives, you first have to identify which one is dependent and which one is independent. So whenever you get an expression, it is generally, most of the time, whatever is given on the left hand side, generally that is the dependent variable, and the one given on the right hand side in whatever form they might give you is generally a independent variable. That's a general task. That's a general thing. That's not always true. For example, I give you this expression, but in the question I mentioned that x is some independent variable and y is some dependent variable, then you need to understand that they have intentionally given the expression in the reverse order. I hope you are understanding my point. If I give you a very simple example, let's say there is a car which is running with so and so speed, and so now you are going to find a relation between the time taken and the distance covered. I repeat, the time taken and the distance covered. Now I'm sure you understand that time is independent variable. You are not going to regulate the time. In fact, you're going to calculate the distance covered in respective time. Am I correct? So let's say if I get an expression as time is equal to root 3 times the displacement. Now you're not going to say that the displacement is an independent variable and the time is a dependent variable or displacement, that the time changes with the change in displacement. It doesn't happen that way. So in physics, in practical life, you have certain limitations. In mathematics, they are just pure variables. You can take anything as dependent, anything as independent. But here you have certain logic to be applied. So here I have to say the time is an independent variable and the displacement is a dependent variable, and so my expression has to be s is equal to t square by 3. So I have to write s is function of t. I can never write time is function of distance or displacement. That's practically not possible. You cannot regulate the time using the distance or displacement. So most of the time what you're going to find is the time as your independent variable, most of the time, but not always. You can have a relation between different quantities also. Okay, so this first thing is very important. Actually, two things. First, derivative means one big problem is divided into tiny components, such tiny, such small, infinitesimally small, I can say, that all the small components, I can say, they are all equal. So whatever solution you apply for that one small problem, it's applicable for the entire huge problem. So that's the first thing you have learned in derivatives. Second thing which you need to concentrate on is the function of x or y as a function of x, where x is going to be an independent variable, y is going to be a dependent variable. In mathematics, I can have the reverse order, but in physics, it does not go in the reverse order. One thing has to be dependent on the other thing may or may not be dependent on the first thing. So now, when you get an expression, based on that expression, you have to decide which one is dependent variable and which one is independent variable. Based on that, you can further understand how the things are going to go for it. Okay, so please copy this part. This is very important. So guys, I hope you have copied the entire part. And now we are going for the next part of this derivative understanding, that what is exactly derivative means when I take a slope or a graph. Basically what I have taught you right now is just an equation form, correct? So what happens if I have a graph present, and what happens in that scenario? So let's say I have a graph of x versus t. Okay, you can take x as, say, distance, displacement, something, and t is time. Okay, in this scenario, let's say the graph is something like this, just a curve. Now, if I want to find the slope of the graph between 2 points, the slope of graph between 2 points, then basically we take 2 points in the graph as, say, this, let's call it as t1 x1, the coordinates, and over here say t2 x2. So this is like my x coordinate stands for t and the y coordinate stands for x. Okay, so now in this scenario, can I say the slope formula which we have done in schools, I hope you remember, it is actually the difference between the y coordinates upon the difference between the x coordinates. Now it might confuse you a little. To just avoid that confusion, I might write this s over here. So this is s1 and this is s2. Okay, so in this scenario, when I say slope, I want to find y2 minus y1 upon x2 minus x1. That's the formula for slope between 2 points. What I actually mean is, this is my y2 and this is my y1. This is my x2 and this is my x1. So if I extend this, indirectly I am taking this ratio upon this ratio. Basically, I am trying to find the curvature possible with the help of the slope, the vertical height upon the horizontal length. Yes guys, so in this scenario over here we are going to have it as s2 minus s1 upon t2 minus t1, which can be written as delta s upon delta t. So basically, if you understand this by the definition, if you are aware of, the rate of change of displacement with respect to change in time, that's nothing but velocity. So guys, this basically slope gives you the velocity of a body between 2 points, which means it is the average. Yes guys, it is the average. Now what if I want to find something called as instantaneous velocity, the velocity at a given point? In that scenario, don't you think the time gap has to be very tiny? It should be that tiny that the difference between the initial and final should be almost zero, which means the at a given instant. Now to do that, I can say I'll draw the graph again of S versus T, the same curve. Now let's say I want to find the slope or the velocity, because the velocity is nothing but the slope over here, as this given time instant, as some t, the instant of that time. To avoid confusion, again I write this as time. So this is the general x-axis which represents time, and this is that instant where I want to find the velocity. Now don't you think it means the same thing over here, slope, but here the slope delta s and delta t, I can say the delta t is almost 0. To be precise, I can use a word called as tending towards 0. Now what do I exactly mean by tending towards 0? Let's say I say the gap is 0.1 second. You can say it's very small, but it's not very small. If I make it 0.01, yes sir, it's very small, but it's not very small. 0.000000000000001. Don't you think this is very small? But yes, it is not 0 yet. What if I keep on decreasing that time gap, but I do not make it 0? Which means I have both the instant visibly at one point. But yes, there are two instances between which there is a gap, and that gap I can say is so tiny that it is t plus delta t. And that delta t is very small. Right? Which means tending towards 0 but not equal to 0. Because I hope you understand, as per the definition goes, if the denominator becomes 0, the value becomes infinite. Practically not possible. So that is the reason when we cannot go for value equal to 0, mathematics give us a freedom to go for something called as tending towards 0 but not equal to 0. Now how does this help us? Guys, try and understand. I can write this as delta s as ds and delta ts dt, where the d stands for derivative. So derivative of s with respect to time, where the time interval is tending towards 0, that is called as derivative when you are consulting or when you are dealing with the graphs. So basically I'm trying to say, when you are finding the slope of a given graph at a given point, which means the time frame or the x frame, basically whatever is in the x-axis, that gap is so small, so tiny, that you can say it is almost 0 but not equal to 0. And that is what is nothing but the derivative is. So basically, if you talk about graphs, I can say derivative is equivalent to slope of a graph at a given point. Yes, slope of a graph at a given point. So in case of graph, basically it's a slope, and that slope will be at a point, not between 2 points, because between 2 points is average and derivative is not average. Derivative is instantaneous at a given time or at a given point. I hope you are getting this, because this is very important. When you're going to face the MCQs, you are going to face MCQs based on the graphs, and in that scenario, finding the slope will always involve derivatives. So definitely that slope you can find using this scenario, using the derivative, or you have one more method over there where I can say, if I draw a tangent at that given point, and the tangent will make an angle theta with the x-axis. Yes guys, this is the tangent to the curve. Okay, and the theta, the slope can be taken as tan theta. So basically I can say for any graph, if you can draw a tangent at a given point and that tangent makes certain angle with the x-axis, whatever angle, okay, that tan theta for that particular angle, I can say it is going to be your slope. Now you might be wondering, how is that possible? It's quite simple. You can just draw take this as height as y and this as x. So tan theta is going to be y upon x. So if this is applicable for this big triangle, don't you think between these 2 points there will be a triangle again, which is going to be really very tiny. I think you can see that as a dot. So if I enlarge it, that will also make a triangle. Correct? And that will also have a same angle theta, because that line is drawn as a tangent to the point. Which means the tan theta, which is vertical upon horizontal, the same thing we have applied the vertical upon horizontal as the slope for average. The only difference over here is we are not taking 2 points because that gives us the average. We are taking 1 point which gives us the instantaneous value. So basically if you talk about graph, I can say it is the instantaneous slope. So guys, please copy this, because after this we are going or heading towards the formulas of derivatives that you are going to remember and try to learn and by heart them to use them in the numericals. Okay guys, I hope you have copied the entire part. Now we go for the formulas, which is very important. So basically some basic properties and then some examples. After which we'll solve some numericals also for you to understand how to exactly apply this. Okay. So let's go for the first part. Let's say u, v are dependent variable on x. Okay, u, v are dependent variable on x, and you get a function or the derivative as d by dx, that is derivative with respect to x, okay, of, in the bracket, whatever you want to write, and that formula over here is say a times u, or it can be a times v, doesn't matter though. Yes, where a is a constant. So here a is a constant. In that scenario, the constant just comes out, and then we can write the formula as a times du by dx. That's it. Which means the constant into derivative of u with respect to x. So that constant is not going to harm, you can say, our formula. But what if I have derivative with respect to x of only a constant? Yes, when you derivative with respect to x of only a constant, don't you think for a constant the value is not going to change? Which means when the value is not going to change, and if you find the change, basically the derivative is the change, right? You're going to get 0. And that's why the derivative of a constant is always 0. I think it's quite simple, right? Now we go for the third property. What if you have the addition or subtraction of two dependent variables while derivating it with the independent variable? For example, d by dx of u plus v. So you have u plus v and you want to derivative the entire u plus v with respect to x, because u and v both depends on x. Okay, because remember, if any of them is independent of x, then it is treated like a constant. When I say a is a constant, it does not change with x. That's what I mean. Okay, so here I can say when you have the addition, you just separated them as du by dx plus dv by dx. So you just separate them. Similarly for minus sign, even if you have d by dx of u minus v, it will be du by dx minus dv by dx. So it won't make you anything difficult or different for you. Now what if you have multiplication or division, In that scenario, the formula will be affected. So if I go for the multiplication first, d by dx of uv means u into v. So this rule is very famously known as uv rule. Okay, so please remember this as u derivative of v plus v derivative of u. So one time you take u as it is and take the derivative of v, plus second time you take the second component, the v as it is, and derivative of the first term. So first term into derivative of second term plus second term into the derivative of the first term. I guess it's quite simple. Yes guys? So now we go for, what if we have divisions u upon v? Yes, anyone can think of it? If you can think of it, it will be amazing. Yes? Right? Okay, sure. Let's try and do that. It is v derivative of u, same thing, u derivative of v, same thing, but there is a minus sign, and in the denominator we have v square. Yes, in the denominator we have v square. Now this is something thoda sa complicated, I understand and I agree, but yes, this is how it is, you need to remember it. Okay, so u by v, when you have, the derivative will be the similar thing, opposite, like flipped with a minus sign, but in the denominator we have v square. That's something which is extra. So these are certain properties which you need to apply when you get certain complicated equations. Now the last property which I will go for, where I'm going to have one more extra thing apart from u, v and x. Yes, what if w is a dependent variable on u, v? Basically u and v पे depend कर रहा है w. So w is dependent on variable u and u and v is already, we know, dependent on x. So what if I have derivative of w with respect to x? Yes, what if I have derivative of w with respect to x? W is dependent on x, no doubt, but not directly. We don't have a direct linkage. So what do we do over there? Yes, we can do one of the two things. I can have the derivative of w with respect to u into derivative of u with respect to x. This is called as chain rule. It's like for PCB students, this is only for PCB students. Practically what I'm going to say is mathematically not correct, but I'm just saying it for you to simply understand it. It's like multiply and divide by du. If you cancel this, you get back this, right? Mathematical students, please don't take this as a true thing. I know it's completely wrong. Mathematically, this is not allowed because du is going to be very, very small, tending towards 0. You cannot multiply and divide by 0. I know that perfectly. But this is just for remembering for all the PCB students that, guys, multiply divided by du, yaad rakho. I'm just asking you to remember. Okay? Either you can do this because it's dependent on you, or you can also have something like dw by dx to be dw by dv into dv by dx. But guys, never try and do this. Over here du and over here dv. You can't do that. Because u and v, आपस में it's not dependent. It's not dependent with each other. Okay, so you cannot do that. But yes, if you're taking u over here, you have to take u over here also. This is called as chain rule. Now, where exactly are we going to use this? The simplest example I can give you. Just pay attention. Can I write acceleration as rate of change of velocity? I'm sure many of you know this, right? Acceleration as rate of change of velocity. Now, can I do this? dv by dx into dx by dt, where I can say that x is the displacement. So acceleration depends on velocity. We know velocity depends on position or the displacement. So if I do this, can I say I have applied a chain rule. So what if I have expression of acceleration with respect to x given in some question? Simple example, let's take acceleration is equal to x square. We have this expression. Now don't you think acceleration practically is dv by dt? So acceleration is dependent on velocity, the change in velocity. But the velocity is dependent on change in position. So because when you change the position, you can measure the velocity, and when the velocity changes, you can measure the acceleration. Am I right? Which means acceleration directly is not dependent on position, but indirectly it is dependent. So indirectly I am using the help of this velocity to get the relation with the x. So for this kind of expression where acceleration is dependent on x, it's given in the question, then you will need this kind of formula, this kind of relation to solve the sums like this. I hope you are clear with this, guys. Now please copy these properties. These properties are quite important, after which we are just going to add some formulas, some basic formulas of derivatives, which is very important for you to solve any sum. Okay, so please copy this as a heading, properties of derivatives. So guys, I hope you have already copied the entire properties. Now we go ahead for the formulas. Yes, the first formula, very important one, derivative of x raised to n. Yes, derivative of x raised to n with respect to x. So definitely this x depends on x itself. So it's a variable depending on itself, you can say. Correct? Or you can call this x raised to n as function of x, as some y. Okay? So yes, over here I can write this as x raised to n as n x raised to n minus 1. So whatever is the power comes as a multiple, and then the power of x decreases by 1. Now instead of this, if we had something like d by dx of u raised to n, just a condition, just a case. Now we know u is dependent on x, correct? So if we take the derivative of this, can I say definitely it will be n u raised to n minus 1? But don't you think that's the derivative of the function of u, which I can say this is actually w, which is u raised to n. And u is dependent on x. So this equation which we got is nothing but dw by dx, or dw by du actually. Correct? And ahead we have to write du by dx. Now this is the chain rule. I'm sure many of you must have gone crazy. Sir, what you have done? Let me explain this in detail. Let's say w is u raised to n. Okay? So can I say this is as good as d by dx of w? Now I'm sure you remember this is dw by du into du by dx. Correct? Now can I substitute w as u raised to n now? Which means d times u raised to n upon du into du by dx. Now isn't this part same as this part? X, x, u, u. So whatever formula you applied for x, the same formula you are going to apply for u. But further you have something called as du by dx because of the chain rule, which was not present over here, because even if you try to write, you're going to write just dx by dx, which is 1. So it won't make any difference. I hope you're getting it now. So here now I can write this as n u n raised to minus 1 into du by dx. The same thing which we got here. I hope you understood the chain rule now. Okay, because this is quite very important. Okay. So obviously the formula is this, which you need to remember, that whenever you have the power of x as some number, that number becomes a multiple, and the power of that x decreases by 1. Just in case in that you have the chain rule applied, means you have a function which is given dependent on something x or something u, and that u is dependent on the x, and there is no direct dependency, which means if you have x over here, you don't have x, then you have to apply chain rule. That's simple. But if you have x over here and x over here, or y over here, y over here, z over here, z over here, u over here, u over here, both the sides u, definitely don't need to apply chain rule. I hope that's clear. Yes? Okay. So now we go for the second formula, which is d by dx of e raised to x. Yes, it remains the same. So if you have e raised to x, if you take the derivative of that, it remains the same. So that's the second formula. Third formula, if I have d of, sorry, this is bx, my bad. Otherwise that will come as dx by dt. Correct the chain rule. Yes, so d by dx of e raised to say ax. Now you have a constant available over here. Remember the constant just comes out. Same thing is going to happen over here. It is going to be a e raised to ax. Basically, whatever the constant is going to come out. But yes, from the normal sum, where we have the constant, it was just a multiple. Here it is a multiple of the power. So you cannot just remove it from there. It will come also as a multiple. So if it is e raised to x, it remains e raised to x. But if it is e raised to some constant into x, that constant will also come out. Okay? So this will be the third formula. And the fourth one, we'll go for the trigo part now. Derivative of sine is going to be cos. So derivative of cos, many of you must be thinking sine. It is sine, but it is a negative sign. So sine becomes cos after derivative, and cos becomes minus sine. Okay? Please remember this. This is very important because even in the next part, the next video, we are going to deal with integration. In that part also, I am going to use these formulas to help you understand the relation between derivatives and integration. Okay? So now we go for the sixth formula. Derivative of 10x. Yes, the formula is sec square x. It is sec square x. Then we have the formula derivative of sec x. Yes, for this it is sec x and 10x. So you have the sec x formula as sec into 10, sec x into 10x. Then the second last formula comes as d by dx of cot x. I'm sure you understand. It is going to be cosec square x. But guys, cosec square x ke saath saath, there is going to be a minus sign. So this is going to be minus cosec square x. And if I go for d by dx of cosec x, it is going to be minus cosec x into cot x. So in all, there are total 9 formulas and around 5 properties which you need to remember for solving numericals and MCQs based on it. Definitely we are going to practice some examples over here. But before we go ahead for that, you need to copy this so that I can rub the code and we can go ahead. Okay. Yes guys, I hope you have already copied the formulas and the properties and everything. And now we are going to solve some numerical for you to better understand how to apply the derivative. Now definitely before solving the numericals, I would definitely like you to pause the video over here, copy the questions and try to solve this by yourself and then see how I solve it, so that you will understand that how much part you have actually understood and what are the mistakes you are making in the basic derivatives. Okay, so I would request you to copy this, pause the video, solve this and then come back. Okay, so here I'm assuming that you have already tried to solve the sum, and now I'm going to solve the sum for you. So let's go ahead. We want a derivative of these 3 functions. Okay, so I'll go with the first one. Let's say y is equal to f of x, which is x raised to 8. Okay, so definitely we want to find a derivative of it. So we want dy by dx, correct? And that means d by dx of x raised to 8. Now if you remember, there was a formula of d by dx of x raised to n as n x raised to n minus 1. Correct? So if I can say n is 8 over here. And if I apply that formula, I get d by dx just goes away when you apply the formula, right? So n is 8, x raised to 8 minus 1. So my answer is going to be 8 x raised to 7. I guess it's quite simple, right? Guys, now we go for the second sum. Second sum, the y is given as x cube plus sin x. Now if you remember that property, that if you have the addition of the two functions, here one function is x cube and another function is sin of x. So when there is an addition of the two functions, you can apply the derivative to both of them just by distributing the derivative to both of them. Something like this. If you remember, d u plus v by dx was du by dx plus dv by dx. I hope you remember this. So if I say apply over here, it I can say dy by dx will be d by dx of x cube. This is like u for me, and this d by dx of sin x. This is like v for me. Correct? Now x cube, I have to apply the formula x raised to n. That means this is going to be n, that is 3, x raised to 3 minus 1, that is 2. So 3x square. Correct? Plus, I hope you remember the derivative of sine was cos. So here we have cos x. And that's going to be the final answer. So 3x square plus cos x is the derivative of x cube plus sin x. It's that simple, guys. Now let's go for the third one. I can say y is equal to x cube dot sin x. Now it's like u into v. Correct? It's a multiplication. So guys, if you remember, derivative of u into v was actually v derivative of u plus u derivative of v. You can remember the other way around also, because it's an addition, it doesn't matter. You remember in which order, it's completely up to you. Okay? So if I consider v as sin x, so I can say sin x into derivative of x cube plus u is x cube, so x cube into derivative of sin. Correct? Now that means we know the derivative of x cube we just derived as 3x square using this formula. Correct? So 3x square into sin x. So 3x square into sin x plus, we have x cube as it is. Derivative of sin x, we also derived it as cos x. So this is going to be cos x. Now if you want to simplify this, you can definitely take x square common, and then you can write it as final answer as x square bracket 3x sin x plus cos x. Oh sorry, 3 times sin x, the x square is gone out. Over here, x times cos x. And that becomes your final answer. So guys, we have solved all the 3 examples in a quite simple way. Similar things will come in your physics. The only difference which will be in the physics or in practical application is, we are not going to have x and y as general variables. Instead, we will have speed and time, displacement and time, electric field and position, magnetic field and position, n number of things. Over here, you can also have something like momentum and time, or momentum and position. So there are so many variables which are like interdependent, or one depends on the other. Those kind of functions you are going to get. And many a times this will also happen that the equation which is given over here, it might be possible that the equation is something which is hidden in the question. So that is the complicated part which they can, in the MCQs or in the question they can take care of, which cannot be taught actually. If you understand, that is something which you need to understand the question and make an equation out of it. Okay, so that is something called as word problems. Yes guys, if you remember, you have done word problems in school. In word problems, they don't give you directly the formula or directly the data. The data and the formula and the concept is hidden in the question, words basically. So yes, here obviously it will be not as simple as the school word problems, but definitely you have also grown up, so I'm sure you understand how to decipher that entire word problem from it. But still, in case if you find any sum which involves derivative, which involves the trigonometry, or which involves integration, and you find that it's something which I should solve for you, then you can definitely give me that in the comment section, and I will definitely try to solve those sums and make a video of the same to help you out as much as possible. So guys, this is the end of derivatives from my side. I'm definitely going to give you some time to copy this. You can just pause the video and copy the solution in case you have not got it. But at the same time, yes, if you like the video, please hit the like button. That's going to motivate me a lot. And also subscribe to our channel, because that is something which will help me understand that you guys are liking my videos. So I'm going to work even harder for you to make more and more sensible and effective and helpful videos for all of you. Thank you very much. This is Shrenik Shah signing off. Bye bye. Let's meet in the third part of this mathematics series for integration. Okay.